Hi ladies and gentlemen, this is section 3.2, Theorems about perpendicular lines. Our goal is to use theorems relating to perpendicular lines. Our keywords are complementary angles and perpendicular lines. Theorem 3.1 says that all right angles are congruent. Think about that for a second. The big red box here on angle A means right angle. The big red box on angle B means right angle. How much do all right angles equal? 90 degrees. So if this angle A equals 90 degrees and angle B equals 90 degrees, wouldn't they be congruent? So theorem 3.1 says all right angles are congruent because they all equal 90 degrees. So there's your symbols. The measure of angle A equals 90 and the measure of angle B equals 90, then they're congruent. Theorem 3.2 talks about perpendicular lines. So if two lines are perpendicular, then they intersect to form four right angles. So right here you have a red box, which means angle 1 equals 90 degrees. So think about that. If angle 1 is 90 degrees, doesn't it make sense that angle 2, 3, and 4 would all be 90 degrees? Here is the symbol for perpendicular again. So in symbols, this theorem says if line N is perpendicular to line M, then the measure of angle 1 equals 90 degrees, the measure of angle 2 equals 90 degrees, the measure of angle 3 equals 90 degrees, and the measure of angle 4 equals 90 degrees. So you could also say that, in short form, two perpendicular lines form four right angles. So what does this symbol mean right here? Refresh your memories. Perpendicular. You should have said perpendicular, okay? All right, so perpendicular lines and reasoning. We are going to use this drawing right here. You can take a second to draw it if you want to. I know it's not on your paper, to figure out some information about these different angles. So in the diagram, R is perpendicular to S. There's that notation. R is perpendicular to S, and R is perpendicular to T. So we need to determine whether enough information is given to conclude that the statement is true. So look at angle 3 and angle 5. Okay, so angle 3 and angle 5 right here, they are both marked with big red boxes. So that means that they are each 90 degrees. Okay, so we should say that yes, they are congruent because all right angles are congruent. This is theorem 3.1. So now let's look at angle 4 and 5. Here's 4 right here. Here's 5. Okay, we'll look at 4. 4 is vertical with angle 3. How do vertical angles relate? They're congruent. So then that means that angle 4 is a right angle. Also, we had theorem 3.2 from before that said that all perpendicular lines form four right angles. So we have a few things happening here. Because perpendicular lines form four right angles, angle 4 is a right angle. That's 3.2. And all right angles are congruent. That's 3.1. So if you combine those together, basically what you're saying is 4 is congruent to 3, 3 is congruent to 5, so 4 is congruent to 5. All right angles are congruent. And angle 2 and angle 3, well, if you look over here at angle 2, what do you know about it? Nothing. A whole lot of nothing. So we're going to have to say no because we don't know anything about the measure of angle 2. Okay, so now you have a checkpoint. This should be drawn on your page. Don't know why that came up separate. So in the diagram, G is perpendicular to E. There's that notation again. G is perpendicular to E, and G is perpendicular to F. So we need to determine whether or not these statements are true and why. Okay. So again, 6 and 10, both marked with right angles. So yes, because all right angles are congruent. 7 and 10. Well, 7 is formed at this intersection of G and E, which are perpendicular. Therefore, 7 is a right angle, and all right angles are congruent. So yes, because perpendicular lines form four right angles, and all right angles are congruent. You have to use the two of those combined together, or the transitive property of some sort. Angle 6 and angle 8. Well, here's 6, right angle. Here's 8. What do you know about it? What do you know about it? A whole lot of nothing is what you know about it. So, we can't say those are congruent. We have to say no because we don't know anything about the measure of angle 8. Here are more theorems. These are the last two of the day. So theorem 3.3 says if two lines intersect to form adjacent congruent angles, then the lines are perpendicular. So if angle 1 is congruent to angle 2, then line AC is perpendicular to line BD. Just think about that for a second. You have a line right here. How many degrees is that? 180. And then if these two are each the same, take that 180 degrees that's all the way around, divide it into two equal parts, and now you have 90 degrees here and 90 degrees there. So therefore, you have perpendicular lines. Theorem 3.4, if two sides of adjacent acute angles are perpendicular, then the angles are complementary. I really encourage you to just use your picture. See, there's this big red box again. Big red box means 90 degrees. So angle 3 plus angle 4 equals 90 degrees. Here it is right here written. The measure of angle 3 plus the measure of angle 4 equals 90 degrees. We know that because those two rays were perpendicular. Okay, put a note on there. There's really not a short way to say these. When you explain using one of these theorems, you may say something like the lines are perpendicular because of theorem 3.3, or you could say something like the lines are perpendicular because two lines formed two adjacent congruent angles, therefore the lines are perpendicular. So you can use the number or you can use the name. Just remember the number is not the same in every course. So example 2. This one has a nice pretty helicopter on it. You're going to use theorems about perpendicular lines. In the helicopter, we're wondering whether angle AXB and angle CXB are right angles. Okay. This picture is also on your book, in your book on page 116. So if you look at that, that matches. You've got this line right here, AC. You have this one that's marked with a single arc, and then this angle CXB that's marked with a single arc. Remember, single arc and single arc mean those are equal. So if these two are equal, and then they form this 180 degree line here, then each of them is 90. So if each of them is 90, it's perpendicular. So this is going to be yes by theorem 3.3. If two lines form congruent adjacent angles, then the lines are perpendicular. And I put a note in there, the angles are right angles. Okay, and here's a hint what you can do. You can match your picture to the diagram of the theorems. Those theorems that we saw earlier are in your book, if you're in my actual class. They're in your book on page 114 and 115. They're right next to each other. Look for the picture that looks most like the one you see right here with the helicopter. Okay, just take the helicopter off and look at the blades. That's how you're going to see it. Example 3. In the diagram at the right, EF is perpendicular to EH, and the measure of angle GEH is 30 degrees. Find the value of Y. Looky here, you have a big red box. What's the big red box mean? 90 degrees. So 6y plus 30 should equal 90. Now you just solve it. Subtract your 30 from both sides. You get 6y equals 60. How do you undo multiply? Divide. So divide by 6 on each side, and you get y equals 10. Sorry, that might be getting cut off by the screen, but it should be y equals 10. Okay, hopefully that makes sense. Okay, so now we're going to use some algebra. So here's our diagram. Find the value of the variable, explain your reasoning. It's supposed to be a checkpoint. Look at it for a second. What do you think that 5x is equal to? 180 or 90 or something else? By theorem 3.3, two lines that form adjacent congruent angles are perpendicular, so therefore the angles are right angles. So 5x equals 90. Did you pick right? Divide both sides by 5, and x equals 18. How easy is that? Hopefully pretty easy. If not, you definitely need to see one of us. Okay, here's another one with some algebra. Find the value of the variable. Explain your reasoning. So we know that ray AB is perpendicular to ray AD. There is that notation once again. You've got rays and perpendicular in there. So look at your 36 and your 9y. Hint, 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 big red box. Take a second, set up your equation. What should you get? So here's the explain my reasoning. Since the two rays are perpendicular, the sum of the two angles is 90 degrees. 36 plus 9y equals 90. Subtract your 36 from both sides. You get 9y equals 54. Now how do you undo multiply? Divide by 9, and y equals 6. Does it make sense? Remember, big red box, 90 degrees. It's always a corner. Okay, there's one more I want you to look at. This one might be a little trickier. So you're going to find the value of the variable, which is z this time, and we're still going to explain our reasoning. What do you think's going on? Since the rays are perpendicular, the sum of the two angles is 90 degrees. Once again, we have the big red box right here. We have the information here at the beginning that says KJ, ray KJ is perpendicular to ray KL. Okay, and those two angles are congruent. So there's two ways you can figure this out, but here's the easiest way. Since the angles are the same, you can simply do this. Z is going to equal the 90 divided by 2, because you have 90 degrees divided into two equal angles. So each of those should be 45 degrees. You can set up an equation and solve it that way. Try it. See if you get 45 degrees, and if you do, then you did it right, and it's a viable option. Okay? All right, so that concludes our notes for today. Now I'd like you to answer the questions on your WSQ watch summary question and talk about it in your groups. Then do page 117, numbers 1 through 7 all, 9 through 27 odd, 28 through 35 all, 37 through 49 odd, and turn it into the Foundations of Geometry tray before you leave. That's right, people, before you leave today. All right, thank you very much and have a great day.